It's episode 3.
Okay, let's take a look at the design process.
This is the Hempcrete book by William Stanwitz and Alex Sparrow, and most of what I can tell you about designing for Hempcrete is in this book. Alex also works for a company called UK Hempcrete, and they offer consultancy, so if you're working through the fine detail of a design, I can recommend that you buy a piece of Alex's time, and he will be very patient and very thorough when it comes to stepping you through what you need to know. You can use Hempcrete on walls, ceilings and floors, so you could say that this is the ideal Hempcrete structure. On the floor and ceiling you can place the Hempcrete between the rafters, and here you use a slightly less dense mix to improve the thermal performance. And on the wall, where it's got to support itself, you use a slightly more dense mix and you place it around this supportive timber frame so that the entire thermal envelope of the building is formed using Hempcrete. Next, you need a vapor permeable airtight envelope as well, and that works best if you put it outside the thermal envelope. And you can do that using a lime render or piece of membrane depending on the design. Now, the reason this works so well is that it's simple. All the junctions between floor and wall and ceiling are taken care of. The Hempcrete is mixed and placed on site, so everything's nice and tight, there's no gaps, it performs very well thermally, and it's got very good environmental credentials.
Now, back at the beginning of the project, I think that I naively thought that this simplicity would translate onto my little extension and make it quite quick and easy. But I was wrong about that. Let me explain why that is.
It seems to me that Hempcrete is an excellent material for building a structure from scratch or working in a situation which is unconstrained enough that you can set up something like this that plays to the strengths of the material. But the space that the new extension is going to be in is very highly constrained, so of course it turns out to be about as far from this ideal situation as you can get.
First of all, you've got the floor. Now, you can set up a solid floor using Hempcrete by lifting it off the ground using a free draining material like foam glass granules.
But this extension is attached to the side of a Victorian building, and the underfloor space in a Victorian building is designed to be ventilated. So I need air to pass under the floor of the extension to ventilate the main building. Add to this the usefulness of having an underfloor space that I can put any pipes and cables I've forgotten through, and I soon decided to build a suspended floor like the rest of the Victorian house. You can make a suspended floor using Hempcrete as the insulation between the rafters, but that Hempcrete is not going to perform as well thermally as sheep's wool or recycled plastic quilt or cork or something like that, so you're going to need a thicker floor wedge to create the same thermal performance. The restricted headroom in the extension means that this floor is set up one step downwards from the rest of the building, constraining the floor thickness from above. So if I want to set up a underfloor space as well, that means that there isn't enough floor thickness left to make it out of Hempcrete. So now I've got a design where I need to think about how I'm going to put an airtight vapor permeable seal on the underside of a raised floor, and how I'm going to make the junction between a Hempcrete wall and some other kind of insulation in the floor.
Next is the roof.
The overall height is constrained by the restrictions on light getting to the neighbour's window here, and obviously on the inside I want to have as much headroom as possible, so I need to go for the thinnest roof wedge I can without resorting to a carbon heavy product. I decided to go for sheep's wool insulation in the roof wedge, which gives me enough thermal performance but creates the problem of making this junction between the Hempcrete wall and the fleece in the roof, so that the airtight envelope that's going up the wall continues across the roof.
This is where I was introduced to wood fibre sarking boards, which I'd never heard of. It's a compressed wood fibre panel impregnated with wax that acts as a vapour permeable barrier and a piece of insulation, and lets you make a good seal between the top of the Hempcrete wall and the roof.
The sarking board sits on top of the soft insulation between the rafters, like this, and makes a good join with the Hempcrete here.
The point where the old structure meets the new one also requires some special attention.
At this point here, where the new Hempcrete wall meets the old wall of the house, there are two issues. One is damp protection and the other is how to make an air seal. The Hempcrete wall is sitting on a plinth that's designed to keep the foot of the Hempcrete dry. But of course we can't vouch for how dry the old wall is, so this damp-proof course that goes along the bottom of the Hempcrete is brought up the wall here to protect the Hempcrete wall from the wall of the house. And to make sure there's an air seal, you connect the bricks to the timber using a bead of mastic, the timber to the hempcrete using compressed quilt insulation like sheep's wool, because the hempcrete can pull away slightly as it dries, leaving an air gap. And then the finish, the lime render that goes across the front of the wall, is also sealed to the bricks.
Then there's the issue that part of the structure is a retaining wall.
The ground level on the neighbour's side of the party wall is higher than it is on my side, so some masonry is needed here to hold it up. That masonry retaining wall impinging on the thermal envelope of the building means I'm going to have to change the design again. On the inside, this means that I can't use hempcrete on the bottom part of the party wall. The masonry doesn't leave enough space to make it out of hempcrete and still achieve the right thermal performance. And although this retaining wall is sealed from the outside, you wouldn't in any case normally put hempcrete below the line of the damp-proof course, which is here. So the solution here is to build the retaining wall out of thermalite blocks, which keep a bit of heat in, and then finish it with a 100mm slab of cork insulation. And the cork not only has better thermal performance, it also has an open structure on its face and it's breathable, so it mixes well with the hempcrete. When it comes to putting lime plaster on the wall, you can put it straight over the top of the hempcrete here and then over the cork.
Next up is the party wall itself. At the moment there's a garden wall, 200mm thick, made of bricks, without a damp-proof course or any insulation, on bad foundations, and that needs to be replaced with a wall fit for being one wall of a modern building. Now, for a number of reasons, the idea of setting up a hempcrete wall finished in lime mortar as a party wall is not that appealing to me. First of all, it's because there needs to be a party wall agreement. Technically, 100mm of that 200mm wall belongs to the neighbours, and when that party wall agreement is made, if they hire a party wall surveyor who says, nope, I'm not having it made out of that weird material I've never heard of, then presumably I'm going to waste time and money. But also, if they did accept it, what if something else goes wrong? Remember, the entire system has to be kept breathable with hempcrete, so what happens if they turn up and paint the whole wall with a non-breathable paint, or they let a drain pipe leak into it but I can't see it from my side, or they want to hang a cupboard and they find there's nothing structural to screw into? Once you've made all those considerations, I start to want to make the wall out of something nice and ordinary, like bricks.
And that's how I arrived at this design. There's 100mm of brick cladding on the neighbour's side of the wall, so effectively the bit of the wall that belongs to them is made of bricks, and that's suspended with a 75mm gap off this timber frame that makes up the rest of the structure using stainless steel wall ties. And this cladding is put up with lime mortar, so it retains some of the breathability it needs to work with hempcrete. And the hempcrete infill then goes from this wall to 270mm out here.
So by this point, the promise of a simple, elegant eco-build seems to have disappeared. The building's not even really a hempcrete building anymore. It's made of hempcrete, brick, sheep's wool insulation, cork insulation and compressed wood fibre panels. It's no longer a good example of how simple building with hempcrete can be, but it has become a really good example of the limitations of hempcrete and how to overcome them using other environmentally sound, low-impact materials. So was it a mistake to make it out of hempcrete? I don't think that the problem solving is any harder than it would have been using standard materials. It's just a very steep learning curve if you haven't done it before. Each problem solve adds complexity to the structure until it's really quite a daunting build. So it's important to work that out at the beginning and not be seduced by the siren song of how simple it could have been if it were a situation without a lot of constraints on it.
You could say that this is the ideal hempcrete structure. This, on the other hand, is going to be hard.